that big industry means big spending on energy. And I think that's the really most important thing, is that when you've got a big energy spend, the opportunities are great. And we've seen that with ArcelorMittal, and there's a case study on ArcelorMittal towards the end that I'm going to share with you. The big question, what Faith alluded to, is do you actually replace equipment with more energy efficient equipment? And that's the biggest challenge. You know, a lot of people think that it's just a technical solution. It's not just a technical solution, and it's not so niche. We try to look at it from an overall perspective, because just changing energy efficient components doesn't mean that the energy savings that you attain from those individual components will achieve the savings that you're expecting. It's all about how you operate and how you design that process. So we often look at it as a whole system. It's not just focus on one specific element, like a compressor system or like just the steam boiler. You have to look at the system in entirety. So how do we do that? We have to look at it from both the demand and the supply side. So it's not just about looking at the boiler, the generation side, or the compressed air that you're generating through your compressors going through the system, but it's looking at how they interact with each other and how they influence each other as well. And an example of this through our systems optimizations will come a bit later in pump systems. I've got a couple of examples looking at pump systems, but just to share with you, in the project that we've initiated over the last couple of years, we have 5 different systems that we look at. They're pump systems optimization, motor systems optimization, steam systems optimization, compressed air systems optimization, and fan systems optimization. All of the systems, again, follow the same methodology. So these are tools which will take you to where you need to go. So that thirst of knowledge that Melissa talked about, that individuals have on these plants, you have to satisfy them with something. And following a systematic process, you can actually integrate these energy systems optimizations, which go in depth and don't just scratch the surface. So not what an outsourced vendor might give you, like what Atlas Copco might just do on their compressors. It goes a little bit deeper into that. And it allows you with evaluation of what other vendors might come to you with. So you find a lot of energy managers sitting on plants thinking, how do I evaluate what X company has said to me or what Y company proposal is coming to me, especially with gain sharing models in the marketplace. Faith mentioned, with individual component optimization, you're only looking at about 2 to 5% efficiencies. But when you look at it as a system as a whole, you can actually leverage 10 to 50% efficiency gains. And we've seen this in a number of organizations where you started from looking at things in a holistic perspective. And what do I mean by holistic perspective? Here's a motor, 91% efficient, fantastic. It works really well, but it's coupled to a pump. And when you couple it to a pump, there's losses along the way. And now you're looking at only 59% efficient, right? That's not the end of it, because that pump has to deliver a certain flow through its distribution system. And once you're looking at that system efficiency at the end of the day is only looking at 13%. So all along the way, there are losses, realizing only 13% efficiency at the end of the day. So if you're going to look at any one component in isolation, you're only going to achieve a 2 to 5% efficiency. But looking at it holistically, you can achieve a lot more. And typically, when you're looking at design of plants, and this is historically, I understand we had a historical oversupply of energy during the early years. But typically, you look at a utility electrical feeder. You say, okay, how much do I have so that I can play with? How can I design? And a lot of our plants are over-designed. You're sitting with a transformer, again, another one that's over-designed and also consumes power. Then you're looking at a motor, breaker, or starter, something that starts the motor up. You're looking at the actual motor. Sometimes you have an adjustable speed drive, but not always the case. And then you're looking at the coupling, which I showed you in earlier, the actual pump itself, the distribution system or the fluid system, and then the ultimate goal, right? So that's typically how normal engineers look at it. How do I design something to deliver whatever that ultimate goal is? That's the structure. That's the setup of most of our industrial plants. When we go into plants, we look at it differently. We start to say, how can I match the process and generation needs? At each interface, there were efficiencies. So at each of these phases, there's an efficiency. The goal should be to maximize the cost effectiveness of how the pumping is or how much flow is delivered per unit of energy. And the way we do this is by analyzing in a systematic way. We start by looking at what does the user need. So we look at variations. We look at what seasonal activities do you have? What kind of alternative services? What times are the shifts? Is there any changes like lunch times? We talked about lunch times. We talked about shift changes. We talked about toolbox talks. All of those influences the user need. do we actually know how much you need at that user interface? The specifications often at a certain machine are forgotten. There's no more standard operating procedures. There's nothing in a lot of industries these days. We find that that information is gone. It's gone with the previous maintenance manager. What you also find is then you need to move on to optimizing the use of the service. So have you applied the right operation for it? Are those standard operating procedures still valid? Has your equipment changed? How has it changed? Have you adapted your manual so that it enhances that change? Or is it just verbal knowledge? So the third one is optimization of the distribution of the system. And this was the one where a lot of companies we're seeing these days are investing in equipment. Looking at ultrasonic leak detectors on compressed air. They're looking at trying to explain what the pressure drops are. They're even looking at insulation and advanced areas of insulation. So this is kind of the level where we see some companies are delving into, but not all of them look at that. And then finally, you look at the optimization of the generation of the service. So looking at how can I optimize my boiler? Because now your parameters have changed. You now have a different set of parameters and your boilers can operate in a much more effective manner, delivering a lesser requirement. So again, the demand supply approach that we're talking about is how do you balance it? You don't start looking at how much you can supply, but how much you can actually reduce your demand so that your supply is a lot more cost effective. The training approach. So we've done this and we've shared with our previous presentations that really the bulk of the foundation of this program has been through skills development and training. And typically you start by looking at trainers and co-facilitators who look at a class of national experts. Okay? So the tools that we have are shared with us through these training programs. And we start in a novel way. No other training, in my understanding, specifically on energy, does this any better. We take these candidates who are really interested, and they've developed the interest because they've come to a two-day, where at a two-day advanced level course, we share fundamentals, we share concepts. And these individuals, highly skilled in their various workplaces, start looking and saying, no, I need to take this to another step. I need to actually advance my thinking and my understanding so that I can apply myself. Again, we're coming to that thirst for knowledge of trying to implement. Sometimes it's a burning platform that Renette mentioned earlier. So it depends on the circumstance. But we start with that, and we place them in an environment where we undertake what we call a host plant assessment. Together with the trainers, they walk through an actual assessment. They actually, on the plant, measure certain parameters. They have an understanding of how those parameters should increase your level of analysis, evaluation. Moving from evaluation, they're able then to table a report that can be considered. Similarly, they then go on to undertake an assessment under the guidance of those trainers at candidate plants. So we talked about the savings in our systems optimization. They have also come from candidate plants where individuals that are passionate about what changes they can make can also implement those changes. And therefore, we're seeing savings beyond just what a host plant engagement is. So that's the manner in which we are able to achieve some of the savings that we've seen in the project. So what can be achieved through this system? I had an example which I'm going to skip through because it's actually so valid, but the pump systems example that I have, pump systems case study that I have at the end will really talk to it. This is what we've been able to achieve, okay, through the program. And really, it's the 440 million kilowatt hours here that we focused on. So that component of 1340 gigawatt hours, of that, at least you're looking at about 450, almost 450 gigawatt hours that were prepared through energy systems optimization. And there's a variety of companies that actually have benefited from undertaking either training or actually implementing through our candidate plant assessments and even through demonstration plants some of the savings that they've been able to achieve. The case study, all right. In 2012, when I first joined the project, we were fortunate enough to visit ArcelorMittal to look at their pump systems optimization on their water treatment plant. It was a fortunate time for me as I was just joining the project, and I was able to look at it from a different perspective, so get a real understanding of how a pump systems optimization should be done. And what we did is they painted a picture for us. They said, we're looking in our water treatment plant at what they call a pump farm of 8 pumps, all connected there. And of the 8 pumps, only 2 were always on backup or standby. And the reason why there were 2 on backup and standby is because it was a supercritical area that they were actually dealing with. They were dealing with a safety jacket that enveloped their furnaces. And that to them was so important. Okay. So we analyzed the system at the site. We looked at the 8 pumps. We looked at the manufacturer, the capacity. We looked at the head. We looked at what the motors did. We measured all the parameters that were involved. And the most important ones were what the inlet and outlet temperatures were of that. And from that, we used all of that information. We put it into something called a pump systems assessment tool. That assessment tool gives us an understanding of how the parameters compare to what an optimized system would look like. And then we looked at even efficiencies. We looked at pump curves. We looked at how those pump curves compare with the measured data that we had taken on the site. So all of this is evidence-based. I think that's the critical thing. It's not something that goes about and saying, okay, I think this looks like a 15% saving. It's something that we actually went out and measured. And we said, okay, taking all those measurements, using equipment that was procured by UNIDO for our project, we were able to find savings and analyze the system in a better manner. And what were we able to achieve? So the first one was actually we were able to switch 1 pump off completely while still maintaining the operating requirements. In fact, we were even tempted to say we could switch 2 off. But we said, because it's such a super critical safety consideration, we would safely say 1 pump. Okay. The second one was really that we recognized looking at the pump efficiency curves, not just the manufacturer's curve, but also the curve that of the installed pump curve when it was installed, that refurbishing 1 or more of the pumps would be beneficial. The third one is that we noticed one of the pumps had a bigger than normal impeller. And by trimming the impeller, they may be able to achieve further savings. The fourth element is that it's possible to automate the system and really look at temperature control. So the manner of control that they were using wasn't appropriate. And often we have to reassess and reevaluate, is our control system for our systems optimization still effective? Am I using the right parameters to control? And the last one was really the implemented savings of around 3.3 million rand. And that's the proof of the pudding. The interesting thing, or the takeaway thing today, is that that reinforces the behavior that you're trying to achieve. Just anecdotally, just before I presented this, I said to Renette, you know what, I'm presenting this today. And she said, wow, you know, I'm so impressed by what the water treatment plant personnel have done. They've taken the awareness just by being influenced through this training exercise. And now the language across the plant is one of interrogation. So if there's a demand requirement, they look at that demand requirement and say, is it necessary? They interrogate it. Whereas before it was always, we just supply whatever they ask for. They now understand that there's an energy consumption aspect to it. That's all I have to share. Thank you.